Welcome to our walkthrough session on data wrangling. So what is data wrangling? Well, basically, data wrangling is very similar to this. Yes, data wrangling is kind of like that. It's like a magician and a hat trick, right? First, Bullwinkle pulled a monster out of the hat, and then he pulled a tiger out of his hat, and then a rhinoceros, I believe, right? And data transformation is kind of like that. The hat never changes, but the form of what you pull out of it, that is the way in which you display or in which you choose to work with the data, that's what changes. And this is what data wrangling is all about. There are two aspects to data wrangling: dimensionality reduction, which we'll go into now, and data transformation, which we'll go into later. In this example, we are working again with our adult data set and with NumPy, Pandas, and Matplotlib. I'm going to load my adult data set and I'm going to put it into a data frame I'm naming adult, and I'm going to display the first few lines. Here we go. And now let's get started. Before we get to our programming, let's think about a couple of things. One of the biggest problems that we have when working with data sets is that they're really big. And this also requires from us then to manage their size. That goes for the length of the data set. That's the number of rows or the number of tuples. And the width of the data set, which is the number of columns or the number of features or attributes or whatever you choose to call them. Why is that? Because any computer has only that much processing power available, has only that much memory available, and in the worst case scenario, only that much disk space. And that applies to any local setup as well as to whatever your future company has in the cloud. So the first thing we're going to have to learn is how to downsize data sets so that they take up less space and less processing power. And that's what we're going to do now. The first technique that we're going to talk about is slicing. Slicing and subsetting are very similar to one another, but in slicing a data set, you actually define exactly the indices for the rows and for the columns that you want to display. Here's how this works. You use the iloc operator. The iloc operator is attached to the name of the data frame here. In our case, it will be adult later on. Then it goes iloc and it operates here with the angular brackets. The angular brackets have two sections. They have the first section for the rows that you want to display, in our case 0 through 5, and the second section is after the comma for the columns that you want to display. And again, these are the index numbers of the columns, right? So df.iloc 0 through 5, comma, and then nothing will show you the rows with the indices 0 through 4. That's the first 5 rows. And df.iloc and then just a colon, comma, and then 0 through 5 will show you the first 5 columns. Now, what's new is that you have to use a colon here in order to ensure that you don't get an error. If you want to display the first 5 rows and the first 5 columns, then you give the iloc operator the first 5 rows and the first 5 columns to display. Let's see what that looks like. So here we are going to look at the first 5 rows. Adult.iloc 0 through 5, and there you go. And as you see here, we have indices 0 through 4. It's the first 5 rows, right? But we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, all 12 attributes that we're showing here because we have not defined the number of attributes or the number of columns that we want to show. Now, what if we want to display only the first 5 columns? Then we type adult iloc, and then we need to include the colon here, and then 0 through 5. And then we will see the first 5 columns. First 5 columns here: age, work, class, education, education years, and marital status, like these here. And we're seeing all of the rows. That's because we have not specified any rows. We just have an empty colon here. So if we want to display the first 5 columns, the first 5 rows, then we type adult iloc, and then 0 through 5. That's for the rows. And now we specify the columns, 0 through 5. There you go. And then if I want to save the first 5 columns, the first 5 rows to my own data frame, then I'm going to call this adult Sonia Short. And then I'm going to use this code here that I have up here. And I'm going to put this in there, and just because I want to see my data, I'm going to display it as well. So as we can see here, the first 5 rows and the first 5 columns are now inside my adult Sonia Short data frame, and when I display my adult Sonia Short data frame, this is what I see. Well, I promised you that we'll also be talking about subsetting. There is a big difference between subsetting and slicing in that with subsetting, yes, you can determine which rows to display, but you cannot directly determine, as you can hear, which columns to display. You can specify the columns in slicing, you cannot specify them in subsetting. However, subsetting is kind of like setting up a filter that filters out only specific data based on the criteria that you specify. Let's see how that works. Here, for example, if we want to see everybody who is 90 years old in our adult data set, I'm going to tell Python, look at the adult data set. In the adult data set, look at the age column here, and then pick all rows in which the age matches 90. Now note that matches is always a double equal sign. This is not math. This is literally a comparison, and when we compare, we need a double equal sign. And then we see here all the rows from our adult data set in which our age is 90 years old. All right, so if we want to find all the people who are younger than 20, all we do is, instead of saying match on 90, we're going to tell Python in the age column, match on everybody who is younger than 20. That is less than or equal to 20. And what we're seeing here is everybody who is 19, 20, 19, 18, 17, and so on. Now, I'm not going to show you how to do this with people who are older than 75. You got to try this by yourself. Now, so far, we have filtered on numbers in the age attribute. It's also possible to filter on strings, but then you're going to need single quotes or double quotes. So, for example, if I want to filter all the people whose education is the bachelor's degree, I use basically the same syntax as before. Here, the only thing I do differently here is, of course, with a different attribute, and then match on, remember the double equal sign, and then my string here, and that is a single quote and bachelor's. Now, if you set a filter for something that does not exist in the data set, you will get an error. So here I'm going to eliminate the S at the end, and you're seeing this is your error. You're not going to see anything because there is no bachelor in education. There's only bachelors. So getting your string correct That is the most important thing, and this is where most of the errors lie. So now we have everything that we need in order to build a reduced data set. Remember, we want to work as much as possible with reduced data sets because we don't want to put stress on the hardware. And honestly, having too many data to look through, that's always a bit stressful also when programming. So let's make sure that we know how to reduce our data frames such that we can always work with only the data that we need in order to make a good data-driven decision. Here, for example, we're going to build a smaller data frame that consists only of our age, education, and sex features. So how do I do this? By saying, well, I'm going to use the adult data frame. That's the big one, right? And then I'm going to put in it just age, education, and sex. Here is what I'm displaying. And if I want to save this into a data frame, then of course I will say I'm going to reduced data, and then I will use this command and save it in reduced data. Of course, we're not seeing anything here, but if I display my reduced data, then you're seeing the contents of this data frame. Of course, now we have built a data set with only 3 features, but it still has all of these rows. If I wanted to select my columns as well, or my features as well as the rows in one fell swoop, I would have to use the iLock operator. And that's what we're seeing here. So here I can build my customized data set, my customized subset of my adult data set by slicing. And here's how I do this: adult.ilock, and then I say, well, here are the rows that I want, rows 0 through 5, right? Which gives me indices 0 through 4, or the first 5 rows. And then I'm going to tell it, well, I want the following columns. I want the columns with the index 0, index 1, 7, 10, and 11. Remember, indices always start at 0, right? So we have 12 columns. Last column is income USD, but the index number for that column will be 11. And then I get in one row of code, I get a shortened data set, and I get a data set that includes only the columns that I really want to work with. But of course, that cannot be the only answer, especially if we want to apply a row filter. So we can combine that. We can combine the iLock with the, well, I want my first rows and my first 5 rows here, and I want these columns here, but I also want only those rows and columns for any of the rows that contain bachelors in the education attribute. So here I'm combining a row filter, namely education that matches bachelors, with an iLock operator that gives me the specified number of rows and the specified columns. So here is what this looks like. I am filtering first on the bachelor's value in the education attribute, and then from that result I am picking the first 5 rows that contain bachelors, and you see it's the indices are different. It's not 0 through 4 anymore. It's really the indices of all the rows that contain bachelors, and then the columns 0, 1, 2, 10, and 11. All right, now let's build an adult small data frame with rows 70 through 80 and with all of the columns. How would you do that? So the first part for this is easy, right? Adult small equals adult.ilock. But now let's start thinking about this. Rows 70 through 80. Now our indices start at 0. So row 70 has what index number? It has index number 69, right? And row 80 will not have index number 80. It will have index number 79. And here we go. And all columns. So now let's take a look at adult small. And here we are. So now that we know how to build a data frame based on a filter, based on selected rows, based on selected columns, let's talk about how to choose the rows and the columns that we're selecting. For that, we're going to have to talk about dimensionality reduction. Dimensionality reduction also has a similar goal as our slicing and our subsetting and our filtering, because the goal is always to make the data set smaller so that it's easier for the machine and for you to handle. But the reasons are different. With our previous approaches, we've just focused on what we want to see and what we can work with. With dimensionality reduction, we're going to let our data tell us what would be a good idea to work with. So while dimensionality reduction also aims to make a dataset smaller and shorter, we really need to analyze the data themselves to show us ways in which they can be summarized and simplified. And dimensionality reduction can happen based on columns, based on rows, based on bins and buckets, and we'll talk about what the difference is between the two, and also based on the normalization of attribute values. So we're going to take a look at column-based and row-based dimensionality reduction first. Talking about column-based dimensionality reduction. Let's scroll up to our data set here. This is good enough. So here we have our marital status here, and then we have our relationship here. Well, you know, never married, not in family, that kind of is the same, right? Married, civilian spouse, husband, married, civilian spouse, husband. Let's see if there is some sort of relationship between married and husband, for example, here, or separated and child, right? Let's see if there is any kind of one-to-one relationship. So doing column-based dimensionality reduction means we're going to compare the contents of two columns to see if there is a one-to-one relationship between the values that they display. So here we are going to look at relationship and marital status. I'm going to call the data frame household. And then I want to see how the marital status attribute behaves in relation to the relationship attribute. So I'm going to group this by, and you may remember this group by operator from any kind of database work that you've done before. That will give us the categories here for relationship, and then the marital status will show us whether the values that we're seeing here are always the same or if they're different. And you've already seen the result here. Okay, relationship husband is married civilian spouse, married civilian spouse, married. That kind of looks like it's probably going to always have the same marital status. Let's see, relationship not in family, never married, divorced. Married spouse absent, never. Okay, so here we're already seeing that the marital status value is different, right? We have never married, we have divorced, married spouse absent. Here, in contrast, we have husband, married civilian spouse, married civilian spouse. So those are the same. Let's take a look at other relative. Married civilian spouse, never married. Oh, well, okay, so same behavior as not in family. How about own child? Never married, never married, never married. That's kind of similar to husband here with married civilian spouse. Unmarried, never married, divorced, separated, divorced. Okay, so that unmarried relationship category behaves a little bit like the not in family. And then wife is married civilian spouse, married Air Force. Oh, okay. So that also does not have a one-to-one relationship between the values that we're seeing in marital status and the values that we're seeing in relationship. Okay, so does this mean that both columns essentially contain the same values? It means that they do not. Let's move on. Will it make any difference if we group by marital status towards relationship? Well, let's see. Here we have the values for marital status we previously saw on the right side here. Now they show up on the left side because they are our grouping attribute. And let's see, not in family, unmarried. Okay, so we are already seeing for our divorced category here, we have a number of categories under relationship. And I think we can see that if it works one way, or it doesn't work one way, it won't work the other way around. So now let's display this in a matrix. We are going to group by relationship, and then we are going to pull out only the unique values for marital status that are paired with the specific relationship category that we are looking at. So for husband, as a relationship category, the unique values in marital status are married civilian spouse and married Air Force spouse. We get the same thing for wife. That's not surprising, right? And then we are seeing for other relative here, we're seeing married civilian spouse, never married, separated, and so on. And there are more values hiding here behind the ellipses. And we're seeing that really, even if we build a matrix, that does not change any of the results that we've already seen here. And not surprisingly, what would happen if you use not relationship, but marital status as the index? Why don't you try that out and see what happens? So here we've seen really that between relationship and marital status, there is no one-to-one equivalency between the values, right? What we have, in fact, is a one-to-many relationship and a many-to-one relationship. Let's go back to our data set and take a look and see, education and education years. Well, wouldn't having a bachelor's degree mean that you would always have 13 years of education? Let's see, bachelor's 13, bachelor's 13. And then we have some college here. Would that mean that you would always have 10 years of education? Let's see here, some college 10, some college 10. It looks like there may be a one-to-one relationship. Let's test that. So we're going down here. And we're going to build a smaller data frame. Remember, we want to work only with the data that we need. It's better for our processor. It's faster as well. So we're going to build a smaller degree data frame, and I'm going to pick out from my adult data set the education years and the education attribute. And instead of building the big list that we saw up here, I'm just going to build the matrix with the unique values, and then we'll have a very quick overview. I'm going to call this degree 2. So I'm going to say, go to my degree data frame that I've built here of these two attributes, group by education years. So that's what we're going to see on the left side. And then apply my transformation here. It's called a lambda transformation for education attribute, and display only the unique combinations. And what we're seeing here is, in fact, a one-to-one relationship. Look at this. Education years, we're seeing the unique values here from 1 through 16. And for the education attributes, we're seeing the categories preschool, 1st through 4th, and so on and so on. And we're seeing there's really only one value for each category in education years. And that's very different from the matrix that we see above here with between relationship and marital status, where we saw the categories in relationship. And here we saw several categories under marital status that were combined in our data set with the relationship category. So since we have here a one-to-one relationship, we could really, if we wanted to, and we do want to, reduce our data frame by eliminating one of these attributes. So the next question then is, which of these attributes should I pick? And here, if there isn't any particular reason, going forward, I would always choose the numeric attribute because it is easier and more convenient to do math with numbers than to do any kind of math with strings, of course, which is very limited. So there's two ways in which we can eliminate the education attribute. The first one is with this technique here, in which we just build a smaller data frame with only the attributes that we want to, that would require of us. Remember, we have 12 attributes. If we leave one out, that's 11. We would have to accurately type 11 attribute names here. That may be a little bit tedious. Instead, we can also use the pandas drop function. Here is how the pandas drop function works. We are going to build an adult 4 data frame here. And instead of typing all of the attribute names, I'm going to say, well, my adult 4 data frame, I want you to look at the adult data frame, then drop the education attribute. And remember here, the attributes are always in the square brackets here. And of course, drop is the function, so we have the parentheses. And then I'm going to use axis equals 1, means it's a column, right? I want you to drop the education column when you build my adult 4 data frame. So what does my adult 4 data frame then look like? Let's take a look. And here is what we're seeing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we know we've lost one column. And if you look here, do you see the education column anywhere? No, you don't. All you see is education years. This is what we would call column-based reduction. So you've just learned how to use the drop command to remove columns from a data set. Now we're going to use the drop command in a little bit to remove specific rows from the data set. How that works is a little bit different. First of all, our axis definition is going to become axis 0. 0 is the row axis. 1 is the column axis, but that's not all. Before we get there though, let's first look at label-based deletion itself. For that, we're going to build an adult 5 data frame from our adult data frame. And then if I, for example, want to delete all the rows that contain the value of white, how do I do that? Well, we know that deleting rows requires looking at the index numbers of each row, right? Or the index value of each row. So if I want to delete all the rows that contain the value of white in my race attribute, then I will need to use the race attribute as my row index. So in other words, my index changes from these numbers here to the values that I have in this race attribute. I'm going to set this race attribute value that you're seeing for each row here as the index for each row. Here's how this works. I'm going to first build my adult 5 data frame, and then I'm going to tell my adult 5 data frame, set the index from the index numbers here to the contents of the race attribute. Here's what this looks like. What you're seeing here is instead of the index numbers, now we have set our race value as the attribute. So now it's quite easy to filter out the attributes where race is set to white and just delete them, right? Or drop them. That's how this works. Adult 5, which now has race as its index number. Now we can say, well, drop all the ones with all the rows that have white on axis 0. This here is axis 0, right, as the label, as the row index. And then we're seeing that we don't have in our first 5 rows here, we don't have our race white anymore. So now we have just seen how to use the contents of the race attribute as a filter for deleting rows selectively or deleting a whole group of rows based on, here in our case, the race index. I can also decide to delete rows with very specific indices, right? With specific index labels. And here we're going back up to these index labels. So I can pick, for example, that I want to delete the row with the index 0, 1, and 5. And for that, I'm going to have to specify the specific row index numbers that I want to delete, and I have to specify that this is axis 0 because axis 0 is the row axis. If I set the axis to 1, I will drop my first column, my second column, and my sixth column, right? So axis 0 means rows, axis 1 means columns. So here, take a look at this. You see how I have now dropped my columns with index 0 and 1, these two here, and I have dropped my row with index 5, and you can see that because there's a 5 missing right here. Now it's up to you to practice what you have just learned in terms of dimensionality reduction. So why not build a new adult 5 or adult 6 data frame and use any of the other attribute values here as an index in order to reduce your data set. For example, build a data set with only professional specialty as the occupation, or build a data set for only not in family relationship. Those kinds of things, please be sure to practice the techniques in this workbook. Thank you.